Okay, go.
Alright. Hello, ma'am. Today we'll be demonstrating and explaining our project Amazon Product Review Sentiment Analyzer and Data Visualizer. My name is Akshat Singh and my registration number is 20BC0972.
My name is Jay Jaju. My registration number is 20BC0920.
My name is Arpit Singh and my registration number is 20BC0875.
Good morning, ma'am. My name is Gautam Goyal. Registration number is 20 BCE 2052.
Alright, so I will be providing a brief overview of our project, its advantages, and its convenience. So, the aim of our project is to develop an Amazon Product Review Sentiment Analyzer and data visualizer that automatically scrapes reviews from Amazon and classifies them as positive or negative using machine learning model and presents sentiment analysis in an easy to way understand uh, format. Now, the main advantage of our system or product is that it saves the customer a lot of time rather than going individually through comments, but it also makes them helps them make a good purchasing decision. It is also in addition to its time saving benefits, our system is also valuable because it provides an objective analysis of the reviews, because often reviews are biased, which we have overcome through our machine learning models. Another convenience and scalability advantage of our project is that it keeps on scraping as the Amazon products get added and the comments get added, and we can also provide Amazon with an API for each and every product, thus increasing its scalability as well as its convenience. I'd like to pass on the presentation to Unmukh Singh, who will explain about the datasets. Thank you.
Right, thank you, Akshat. Now I'll be explaining about the dataset as well as the models that we have used for the purpose of our project. So the dataset that we have used is basically an Amazon dataset that contains over 7 million reviews written by Amazon customers between 1995 and 2015. However, we have only used 30,000 rows for the purpose of our project. Each review in the dataset includes information such as the customer ID, product ID, date of review, the review text, and the rating given by the customer ranging from 1 to 5, and a label indicating whether the review was deemed helpful or not by other Amazon users. This dataset provides a valuable resource for researchers and data scientists who are interested in conducting sentiment analysis, natural language processing, or machine learning tasks on Amazon product reviews in the PC category. So, as for the data set, like I said, we will only be using 30,000 rows for the working of our project. So first, it's so step one is we load it into our project, and then we remove all the HTML elements from the reviews as well as the special characters and numbers from the reviews. Convert all reviews into lowercase as well as remove all the stop words. So basically, we are cleaning the data set and then converting it into a training set and a testing set. After all of that is done, we then use first. Step one is to use the SVC module. After we use the SVC module, we found out that we got uh, an accuracy of 91%. Upon using the upon using the random forest module, we found out that we had an accuracy of 87%. After that, we used KDLS neighbor model or the KNN model, and we found out that we had an accuracy of 84%. After that, we used the logistic regression module, which again gave us an accuracy of 91%. And lastly, we used the knife-based classifier model, which gave us an accuracy of 87%. So among all these models, since we had the highest accuracy with logistic regression model, we chose that for our project to give us to maximally accurate reviews, Amazon reviews by the customers. Next, I'll be talking about the code that powers our social now. So Step 1 is to load the Excel file into a pandas data frame and then create a new network X graph. Network X is basically a Python library that is used for working with graphs and networks. It provides tools for creating, manipulating, as well as analyzing graphs and networks and can be used for a wide variety of applications such as social network analysis, transportation network analysis, biological network analysis, etc. So now we then create a node, which in this case is Apple TV, as well as we create edges and label them as positive and negative, and then we connect them to Apple TV. After that, we'll be creating a color map to map product as blue, positive comments as green, negative comments as red, as well as customer reviews as orange. After that, we will add nodes to our data frame where if sentiment is equal to 1, we'll classify it as positive, and if sentiment is not 1, it's anything other than 1, it's classified as negative. And then we'll date the node colors list based on the node type. So if node is Apple TV, it will be colored blue in this case. If it's sentiment, it will be colored green or red, depending on whether it's a positive sentiment or a negative sentiment. And node types will be colored as orange. After that, we'll visualize the graph using Spring Layout algorithm with different colors for each node class. And finally, our graph will look something like this. Now I'll be handing over the presentation to Gautam here. We'll be talking about the visualization. So over to you, Gautam.
Thank you, Unmuk, for the brief information about the data set. Good morning, ma'am. My name is Gautam, and I'll be continuing with the uh, web scraping part and then the visualization part. So, for first of all, for web scraping, first of all, we are taking the ASIN value of each product, which is a unique value for each and every product. So, first we are taking that, and we are going to the review part of 10 pages of the review part in each and every product. First, step one for web scraping is pagiation. In pagiation, what we do is we take the HTML part of each and every page of all the 10 pages and we store it. Next, we go to the parse function. In the parse function, we take the content from the HTML document we just uh, took from the pagiation part. In the parse part, we then take this title, rating, and the body thing from the HTML tag, which is then stored in a JSON file, which is the next function, def save. We just store this in the backend with a JSON file, reviews.json. As you can see, uh, yeah, this is the data we just scrapped, title, rating, and body for each and every review. We go back to the now we go back to the visualization part. First of all, there are three visualization which we have done, which is the bar chart for positive, negative. Second is the bar graph for the stars, first 1 star, 2 star, etc. And third is the pie chart. First, I'll be explaining the positive and the negative bar chart. In the bar chart, we have first imported the bar component for the chart from the chart.js. First, we call the bar chart function, which takes the input from the reviews, and whenever the reviews is changed or updated, this use state function is called automatically. So basically, we have taken a variable initial rating which have two which is an array of two size. First is the positive and the second is the negative. So first is the number of positive and second the number of negative. First we have initialized as 0. Now we traverse through each and every review. If the review is positive, we increment the 0 index, that is the positive one. Else we increment the first index, that is the negative one. Next, we store the review we got into a plot data constant, which we will be using to plot the data in which the labels are positive, negative, and in the bar. Now we go to the bar component, which is self implemented component for the from the chart.js. So that is ever. Next, we go to the bar graph, which take the ratings, 5 stars from the review, and plot a graph against it. So first of all, we call the bar function similarly, and now we initialize the 5 ratings, 1, 2, 3, 4, 5 ratings as index 0, 1, 2, 3, 4. Next, we traverse through each and every review, and we see what the review is. If it is a 1 star, we increment the zero index, and similarly for the fifth 5 stars we increment the fourth index. Next we store this data into a prod data in which the labels for the x-axis are 1, 2, 3, 4, and 5 in numbers, and the heading for our chart is ratings. The data is the data we just implemented. Next we call the bar function, bar component, which is automatically called and the graph is plotted. Next we go to the pie chart. In the pie chart we have imported the donut component from chart.js. This function we have created to call the pie chart. This is a pie chart function which in which we call similarly the use state function, which is called automatically, and it also has two components, basically positive and negative. We traverse through each and every review, which is a two indexed array, 0 and 0, initialize as 0 and 0. If it is positive, we increment the 0 index, and if it's negative, we increment the first index. Next, we similarly label all the positive and negative reviews data, and in the donut component is called, which makes a shape like a donut, which is a pie chart, and the data which we just called is stored there. Next, I hand over the mic to Jay Jaju, who will be continuing with our project. Thank you.
So now we will go to the overall working of the project. So overall work, the project works like you have to just copy paste the link of a Amazon product into our website. The server will take this is our server. The server will take all the necessary information, like it will extract the ASIN value from the link, and it will give it to the reviews.py, which Gautam told. It will save all the reviews in that reviews.json file, which we can see. Now here there is no predictions if it is a positive and analysis or negative analysis. So for that we have our trained model, which was logistic regression, which we saved as a name of model.pkl. By using this model.pkl, we will classify them as positive and negative, and the results will be appended into the whole data, and it will be saved in predictions.json file. So this is the predictions.json file. As we can see, the title, rating, body, and now the review of the whole body is also appended into the function. This data will be sent to the client side where all the visualization happens. In the visualization, we have one more visualization, which is sociogram of the whole data. It acts like it has a three nodes initially, which is product, the positive node, and the negative node. As soon as the data comes, we will check the group of the node. If it's product, it is 1. If it's positive reviews, it is a group 2. If it's negative review, it is group 3. As soon as the user reviews come, it will be set as a group 4, and the user will be incremented by 1. And it will be set to the nodes in the graph. And now we will set the links of each user with respect to positive reviews or negative reviews. If the product review is negative, the source will be from the negative review node. If else, it is a source from positive review node. The target will be the user, and the value will be -1 or +1 to change the color of the node. And the links will be set. Now, this use effect does all of this using dynamically updation of the web page. Now we have used D3.js to plot the graphs. Here, a basic structure of the graph is formed. Here, all the links which are appended, which are in green or red color, all the nodes are appended into the graph which we formed above. All the text like user text, product name, node name are appended into the graph. And the nodes are forced onto the graph, and the links are also forced. Now the component is returned, and it will look like something tree structure. Now let me show you the demonstration of the website. So we have public and server. So this is the basic website, which looks like this. Now we have to just copy the Amazon product link. So I have one Amazon product link saved here. I will just copy paste the link. So here we can see that this is the ASIN number which our server will dynamically extract from the link. Now if I click on search button, it will start extracting the reviews. Is generating the just as soon as the report is generated, it will be shown to the client. Now we have developed the UI of the website such that the user can just by looking at the color of the card, he can get it's a negative review or positive review, and the accuracy of the model is high. As we can see that the comment is worst is the phone weight is more and not handy, so it's just commented it as negative review. The phone quality is good, awesome. iPhone 12 is awesome phone, and the service provided Amazon, it's a positive review, and it is classified as positive. Here we have network problem and heating issues, classified negative. So our model is working fine. Now, if I click on the visualize data, so we got all the visualizations here. Here we have a bar graph of ratings: 1, 2, 3, 5. 4 users have rating as 1, 6 users has rating as 5. On the graph, we have 3 reviews negative, 7 reviews as positive. This is the bar graph for the same. Here we have sociogram, which tells us the product. It has negative reviews, positive reviews. So user 3, user 8, user 7, user 5, user 10, user 2 are connected to the positive reviews, and user 6 also. Only 3 users are connected to negative reviews, which we can see like from this negative reviews, only 3 negative reviews are there. So the user will get a in detail in detail visualization about the product reviews. Now if I click on the summarize data, it gives me a summary of data. The iPhone 12 is a good phone, but its weight makes it difficult to use, and the camera and video quality are not as good as other phones. It has also poor filter options and slow charging speed. It gives the summary of all the reviews, so it's not like generated from somewhere from Wikipedia or something else. It shows what the users have commented on the comments, and it uses OpenAI API to summarize the data. So in short, we have made a tool for a user by which user can get in-depth analysis of the reviews of the product, as the reviews are the most valuable part of a product, by which user can just
No.
know about what he has to buy and what not. I can show another demo, Amazon website. So this is okay, this is the whole demo. Uh, we can also provide an API for this project to Amazon, so that their users can just easily analyze the product more efficiently in less time complexity and less time consuming process. So this was our project. Thank you for listening to us.
Thank
Thank
you.
you, ma'am.
Thank you.